We will share this recording after the webinar if you want to come back and review anything. I guess just to answer the first question before we start, I see John Chow asking, what textbook do you follow for USACO? We actually prefer not to use a textbook because the USACO website is really good at posting their past problems, including and up through last year's contests. So our instructors prefer to prepare based on those problems and then give demonstration of those in the prep courses, which is an open resource for any students who'd like to use it as well. Anybody can go on their website, which I'll be showing in a little bit, and use those past contests to practice. But I'm going to go ahead and share my screen with today's presentation. We'll mostly be going off these slides and occasionally taking a chance to visit some other websites. And here we go. And so you'll see here up on the screen, we're talking about computer science competitions, USACO and the ACSL primarily, though I'm happy to talk about other competitions as well. I think they all have their merits. And I know for a lot of you, this will be about choosing a computer science contest for your child to participate in. Or if they're already participating in one, maybe you're just gathering more information. Both great reasons to be here. So this kind of, for me, begs the question, why should students even code competitively? I mean, computer science might seem like sort of a niche skill, and then doing it competitively might even be more obscure. But I do think there's a lot of merit to it. Among other things, this can be a really great source of personal learning and growth for students. And I know for myself, doing competitions as a kid, even though I wasn't particularly competitive, made things a lot more fun and growth-oriented, and helped me find the motivation to discover new things about myself. And I think the same can be true for computer science, especially sometimes students who've spent a lot of time learning computer science might not want to compete in as many other things, but having something that fits their strengths can be really empowering. And it can be a lot of fun. So whether they're competing as part of a team or just on their own, they've been putting the work into learning the stuff. So you might as well find a way to enjoy it as well. And the question that a lot of people ask is, does this matter down the line? And I believe the answer is yes. I think college admissions are getting more and more in tune with these year by year, starting to realize the value of actually understanding students' passions and not just a test score or a high school GPA. There's more and more focus now than ever on extracurriculars, and admission staff are understanding that these are really valuable, that contests the students participate in show a lot of dedication and a lot of the same skills that would be valued at a university. Apart from all this, I feel like from what I've seen on our ACSL teams and our study groups, students can also form a sense of community around these, even if they're competing individually. You want the people in your class to do well as well. There isn't really an atmosphere of like, if I do well, you do poorly, or vice versa. So students on a team or in a team setting can gain a lot of camaraderie from that as well. As folks keep trickling in, I think we're up to a little over 50 participants, which is great. I'm going to go ahead and make our first poll go live, which is just a brief entry poll, find out a little bit about where you're coming from and maybe where your student's coming from. Feel free to answer, and I can share the results when it's done. But going forward, I figured I'd just go through some of the different age groups of students who might participate in these competitions. And the first group is younger students, which I would categorize as grades 3 to 6. So students who aren't quite in middle school yet are still really figuring themselves out through elementary school and maybe that first year of middle school. May not be at the point where they're writing complex programs, and that's totally fine. Most of these competitions focus on what's called computational thinking. So students can learn a skill that might be similar to solving a math problem, but it's really more thinking like a computer, and use that to participate in the American Computer Science League at the elementary level, which I'll speak more about in a bit. That contest doesn't involve any programming, so they can actually do the short answers problems, and that's the entire contest. And I believe there's also a pretty short time limit on that, like 30 to 45 minutes. So they're not going to be staring at this paper test for an hour. It's meant to fit their attention span and meant to fit their learning styles as well. We look at some practice problems, you'll see maybe not the skills that any 3rd to 6th grader would know, but within the realm of what they could learn, especially if they've done some computer science. Some of the other options for students this age that I've seen be really fun for them, we have our robotics clubs that at a beginner level are right around this level of experience. If your student's already taking your classes, they might be in like the fun 2A to fun 3A range of level 2, level 3 KT bike classes. And this is also where we start exposing students to some in-house challenges. One we did for years was Babris, which I would still encourage students to participate in. I think it's really fun. They have all these themed problems. And if I open this up, this might not work as well as I had hoped. You can see there's the different groups within Babris they can compete in. And each one, even down to 6 years old, you can find some practice problems and start to answer things that seem pretty accessible to kids. It's like, here are some rules, which bugs can go with which branches. You can sort of connect them and then save your answer, see if it's correct. So great way for kids to get started if this is within their interests. Another thing we've tried is an in-class challenge and monthly, what used to be monthly or quarterly contests. We're hoping to bring these back next year because it took a brief hiatus over the summer just to focus on other things and figure out how to publicize these a bit more. But we do have plenty of these beginner contests, which are in Java blocks, the same thing we teach in our level 1, level 2 classes, and they're all auto-graded as well. So a student can try these contests. They can see how they do as the problems get progressively harder and harder. And they can feel that same sense of accomplishment when they do something that they know was presented as a time contest at one point, even though none of these are currently live. They were live for a week back in March or all the way through the end of the summer. And anything with the beginner tag is appropriate for students, we think, grades 3 through 6. They have this background in Java blocks. And students with a little bit of processing knowledge, maybe in our level 3 through level 4 of our curriculum, can do intermediate, and then level 5, level 6 can do advanced. We'll talk more about those in a little bit. But one of the distinctions of students at this level is that they are probably still using block-based code. They aren't typing things out yet. And so we want to make contests accessible for them as well. Going forward, we have competitions for those intermediate coders that I mentioned a minute ago. Think of intermediate as probably ages 12 through 15, grade 6 up through the beginning of high school. And students at this level are starting to really figure out their interests. Maybe in elementary school, they're just figuring out who they were as a person. Now they might know a little bit more about what they like. Students might be getting into sports, might be discovering their favorite subjects. And I believe this is an important age because as you're figuring that stuff out, you really want to end up with interests that'll stick with you. Not something you'll just decide you don't like in a couple of years and then have spent a lot of time on. So if a student is interested in computer science, I think it might be an interest that stays with them for life. This can be a great time for them to start trying more of these competitions, seeing which things really fit their interests. And we have more options for that as well. Starting with the ACSL or American Computer Science League junior level, that's a slightly more expanded contest from the elementary level. It does have a programming section in it. And students in that prep class will learn skills beyond what we teach in our core classes, or even if they're preparing for these contests on their own, they'll be learning to submit code for other people to review that's in a development environment that professional coders might use. They're learning to read user input and generate output that can match some test cases. And those are the same skills that are pretty uniform, ubiquitous, even at the USACO level, all the way up through the end of high school. So learning them at this young age can really translate fairly well and be valuable at the college level and beyond. Apart from ACSL though, we still have our in-house challenge, which we'll see in class and contests, just giving them that chance to try something fun and semi-competitive, even if they're just competing against themselves. Robotics club's still an option, and students might be starting to participate in science fairs now too, either through their own school or finding something more local or regional. They can start to really show off their STEM skills and kind of nerd out about the topics that they're most interested and excited about. And as I said, the distinction here is that students, if they're taking our classes, are probably level 3 or 4, so Fund 3A through CS0000B, and they're starting to be proficient in typed out code. They're learning about things like arrays and loops, and maybe even a little bit of classes, object-oriented programming. And those skills are building their knowledge of computer science and giving them a lot more tools to solve these problems. Whether or not they realize it, they're already solving a lot of problems as they code just by going through these classes or making little games. And so seeing that in a contest as well and having that affirmation can be really rewarding. When students get to high school, some of our students even hit this before high school, but as a general grouping, I'd call this high school age and beyond. There really are a lot more opportunities for them. We have the USA Computing Olympiad. If anybody's here from Canada, there's also the Canadian Computing Competition, which is similar to USACO in a lot of ways, though not always. It's something we hope to support more specifically in the future for students who are interested. But then there's also 2 more divisions of ACSL. So intermediate and senior are both intended for students in grade 9 and above. And we actually group these together when we offer prep courses, and I'll talk more about our prep courses near the end. But intermediate and senior are similar enough that students can kind of pick and choose between them which they'd like to compete in. But the senior level is really where they can, I don't know, feel that accomplishment of hitting the end of the line in terms of the ACSL difficulty. They've probably competed in every division at this point, which can feel really cool for them. And it's also a way because we know there's such a wide range of experience in high school. Students may have been coding for 6 years or for 2 years, or this might be their first time, that we don't want to put them in a box. We want them to be able to try different things and not do something that feels overwhelming or feels too easy. And as students gain more experience with these algorithms, they might be ready to start the USACO at the bronze level. And I'll talk more about USACO structure in a little bit. I know that was a pretty common question when we had the registration out. And some of those competitive research opportunities might come within their reach. Things like MIT Primes, where they can apply to do research with a really renowned local or national institution. Things like hackathons, where they can join up with a team of their peers to code and solve a problem and maybe even win prizes. All of these are coming within their reach, and that can be really exciting for students. These used to be things that would only exist at the college level and beyond that are becoming more and more accessible to high schoolers. And same goes if they have independent projects they're excited about. You know, I think any of these things can inspire students to have really creative and insightful independent projects, but the competitions can be a great source of that as well. Before we get into really picking these main competitions apart, how are they different? I'm going to take a quick pause to look at the Q&A. CS tournaments where child can start individually and also in team. Thanks, Rashi. Yeah, that's actually something we'll get into here in a second with these two. So I like that you said individually and also in a team, because that really sums up USACO and ACSL to me. USACO is all individual, and we'll see this in just a moment here. And ACSL is all team-based. So even though students compete on a team for ACSL, they are doing their own work for each of the contests, and then the team receives a score. And I feel like that can be the best of both worlds. Obviously, it's not the same as being on a sports team where you're playing with your teammates, but still having that sense that, oh, we all did well after we all prepared together. I think could be huge for kids to feel that sense of community. And oh, thanks, Wendy, for answering those. I'm going to open up a little graphic too that I think might answer some of these questions, give folks some time to look at it. Hopefully this isn't too tiny, so I'll try and get all the text on the screen at once. But the left column here is USACO, the right is ACSL. And there's a lot of information here. I'll send this out after the seminar too, so that folks can take their time to look at it. But the main things that I noticed here that both have been around for a while, ACSL is more than 40. They're both well, ACSL is more than 40 years old at this point. USACO is more than 30 years old. And that's a long time in the history of computers when you think about how long we've even had desktop and laptop computers, or, smartphones are way younger than either of these. And I think it's telling that these have stood the test of time. Even the format has largely stayed the same. And so some of the main differences are ACSL, you can choose your division. USACO, you must pass each level in order to compete in the next level. Some of the things are the team aspect that I mentioned earlier. So students in ACSL register through a school team. We have KT by school team. Something I'll call out in a bit is that this team is free to join for current students. So I'll probably share that link in the chat soon as well. The sign up if you're interested on this team. There's really no downside to students for signing up and competing. And if you're not a current student, we can still offer that opportunity just for a $50 fee to cover our own registration fees. And that's different from USACO. So USACO, you can sign up individually. Students can sign up for free on their own. It takes a little bit more know-how to get started, but that is, I think, appropriate for the level of challenge. I'll get more into our course offerings in a bit, but both of these have 4 contests throughout the year. So you notice these have fairly similar timelines starting in December. I believe ACSL actually opens in December, but doesn't close until January 18th. They offer a much longer window for each of these contests. And these allow students to prepare throughout the year, not have it be this one time, pent up excitement and probably anxiety for it as well. You can really keep going back to the contest and trying to do better. And in the case of USACO, that's often necessary to pass any of these higher levels, especially students trying to get promoted from silver to gold or from gold to platinum. Gold to platinum especially is very rare and hard to do. We can look at the numbers in a little bit, but it is normal for students to spend multiple contests or even multiple years trying to get promoted in USACO. And we don't see that as failure. We see that as more of like a continued growth, because you're still trying new problems, you're still learning more tools. And I think it's just a great goal to shoot for, to try and progress as far as possible in either of these, really. A note on language while I have this up, because I know coding language comes up fairly often in these conversations. What language should my student learn? And the opinion we hold as a company is that it shouldn't matter too much what they start off learning. What matters more is the concepts. That idea of computational thinking I mentioned earlier really translates pretty far in terms of if you can understand these algorithms, if you know how a computer works and how programs are solved, how problems are solved, the same ideas transfer to different languages. Now, that doesn't mean that a programmer who's advanced in Java can immediately start programming in C. It might be a little challenging at first, but if they take the time, and by time I mean no more than a month or 2 to learn the new syntax, we can see them be very successful. And a note here is that Java, which we choose to teach, works fairly well for all of these, ACSL, USACO. It's also the language used on the advanced placement computer science test. And it does work. Some places or some students prefer to learn C++. It runs a little bit faster. In either case, though, and especially for USACO, writing your answers in Python is discouraged just because it's a bit slower. It's a newer language that has a bit more overhead to it, takes a little bit longer to run. And because of that, we found that student answers don't execute nearly as fast and can sometimes lose them points, even if they know the concepts just as well as someone coding in Java. So does not to say your students shouldn't learn Python. We do still teach Python for things like machine learning that are very data science heavy, but Java is a good one size fits all, and that's why we've chosen it. And I'd be happy to speak more to that as well if folks have questions about particular coding languages. Finally, I'll zoom in real quick because I know this is a common question on contest and problem format. So these two are fairly different, USACO and ACSL, and I think this can really factor into which one students might want to try, whether they want to try one of them or over the other. USACO contest is only 3 to 4 problems per contest, and you're expected to spend about an hour per problem. So these are really hard for students who are this advanced to spend an hour per problem trying to solve it, and a solution might just be a few lines of text. It can be fairly convoluted and take a lot of practice to to get to this point where you're advancing. ACSL, by comparison, I think is more accessible, at least to start. It is just 30 minutes at the elementary level, and think about 30 minutes 4 times a year, 2 hours spread over the course of 6 to 8 months really isn't too bad if they're concerned with the test taking time. And we even see students finish faster if they're well prepared. 5 answers might just take them 15, 20 minutes, and then they can check over their work. And the way it works when you're not in the elementary division, if you're ACSL, junior, intermediate, or senior division, is you have actually 3 days, 72 hours to complete a programming problem. And so the way it works is a contest will remain open for a couple of months. And when you choose to start the programming problem, maybe it's over a weekend, you'll open it up, you'll have it on your computer, and you can keep coming back to it during those 72 hours. And the idea being not that the problem is so hard you need that long, you might just need to write a longer chunk of code. And I found in answering these problems that it tends to be more case by case and really tackling different situations that are very specific rather than the USACO, which is very algorithmic and very holistic problem solving. So again, different formats. The short answer used to be pen and paper. Now it's all administered through a computer because as I may have mentioned in some of the literature about this, the ACSL used to be US only. As of last year, it's open to international students as well because it all went online. There's no reason not to, pretty much. The USACO is also open internationally. And so instead of pen and paper, students anywhere, when we proctor the test, can come online, type their answers, answer through the portal, and then have those saved and scored in the back end through the administrator. I see one more Q&A maybe about this. Oh, how to select the team for ACSL. So an answer to that, I'll scroll up to the top here. ACSL is largely age-based, and the way that works with the divisions and what I might even show here, because I think it's a little bit of a better graphic, is that those divisions are pretty well laid out. If we're looking at starting with elementary, open to students in grade 3 to 6, not a ton of room for interpretation there. If you're not in grade, if you're over grade 6, you shouldn't do elementary. Junior division is for those middle school students, but only up to grade 9. So very age-based, and because of that, not super difficult. You can be a beginner in grades 6 through 9 and still prepare fairly well for this. And if your student is in high school, you'll probably fall in either intermediate or senior. And so that's the most advanced prep club we offer if they want to take the prep club. It's also a choice they can make based on their own experience if they would rather take intermediate or senior level contests. But it does make it a bit easier to choose a level, it being so regimented based on age. So I hope that answered that question. Turning to these slides for a little bit, and I may have covered most of this, but the American Computer Science League has these divisions for students aged 8 through 18. The idea being that no one's too inexperienced to at least try this out. And especially the short answer problems, which I can show in a little bit, are not things that are explicitly taught in coding class, but are, I think, useful skills to learn in terms of way to think. And now you may never have to know what computer number systems are or how to convert between binary numbers and a base 8 or base 16 number. Probably won't come up in a job interview. But learning those numeric skills, much like learning algebra, can just give you the background to go and learn other things that require your brain to work in similar ways. And it's still the excitement of learning something that you know will come up in a competition that you can use to perform well and earn points for yourself and for your school, that I think can be a great motivator as you're learning and preparing for things like this. The other thing that was touched on is the team aspect of ACSL. So when you're on a school team, like the KT Bite team, you'll be grouped with other students who you may or may not know. Some of them might be your classmates in everyday school or in KT Bite classes or in other coding tools. And the schools are charged with administering the contest as well. So the service we offer for all students on our team is creating that space where they can take the contest in a secure environment. They can submit their answers, we proctor that, we handle all the details, and then we'll release results on a leaderboard, basically showing how our students did and how that compares with the rest of the folks who took the ACSL contest that time around. Something I'll highlight a little bit more at the end is that we do have teams for these divisions and prep clubs for each division. So if we were thinking about that graphic again, or the divisions really, the elementary is our ACSL 1 prep club, junior ACSL 2, and then intermediate and senior are the third level. And those are just a great way for students to join every week. It's much less expensive than an actual course because it's a club. And they can come in, still meet with a qualified instructor. Most of our instructors competed in these and did very well when they were students, and practice with their peers as well. They can answer a question or ask a question, hear another student answer. And I've seen that be a huge source of motivation for students who are maybe not sure they could do well at this contest, or not even sure they want to do this contest, but then seeing other students who are excited about it, joining the class can be helpful as well. Just to answer a couple more of these Q&As, an advanced middle schooler could, let's see, I'll click, there we go. An advanced middle schooler could join intermediate or senior, and I guess the benchmark I would put out there is if they're taking our CS01A or 01B class, those are actually college level materials, so they would probably do well in the intermediate level. And I would just say there's no rush, like they don't have to go straight to the senior contest. If they want to try intermediate for a year, see if that's a good level, and then decide about senior after that. I tend to advise students to pick the easier option when it's an option, especially if they're on the younger side, just because it feels a lot better to do too well at something than to do more poorly than you thought you would. And the skills are fairly different from our coding classes, so they would still need to learn how to answer some of those problems, which I'll show in a minute here. To answer a more specific version of that, if your students are in CS01A and 00B, the ACSL teams would probably be either at junior or intermediate level. And the USACO would probably want to wait on USACO until after our CS01B course. So I'll get to more about USACO in a second. But something that really helps there is a more advanced familiarity with this development environment you use called Eclipse. Really any Java or professional programming environment would do, but we prefer to teach students some of the more advanced standard Java concepts in this programming environment for them to do well in the USACO. Now, that's not to say they can't try USACO before. Really, anybody can sign up and try USACO contests, try past contest problems, and I'll share that interface in a little bit. But we encourage students to wait until after CS01B to start taking your prep courses, also so they don't feel overwhelmed. In terms of registration, the team handles all registration. So a link I'll share in a little bit is one that they can use to sign up for a ACSL team. And then once they're on the team, we can also add you to a messaging group on our Signal platform or over email. We'll send these as emails as well. And that can help folks be aware of when the contests are happening. Same will be true for USACO. If you're in a prep course, you'll know when the contest is coming up. And these can help with the timing of things, timing of preparation, and we'll proctor those contests as well in the case of ACSL. I'm going to grab that link right now, just as I'm talking about it, put it in the chat. Let's see, the ACSL club is online. if ACDI is ACSL, you do not need to be in a particular high school to be on an ACSL team. The KT Byte is considered a school that can have a team, which is how we have students who are international as well participating. I will share that ACSL sign up form in case anyone has not seen it yet. That is how you can sign up to be on a team. All of these options are online at the moment. So That is something we'd like to change in the future. We've actually just started offering in-person USACO prep classes again for the first time this fall. And the uptick has been slow, honestly. I think there's still not a ton of people in the Lexington, Massachusetts area who are so excited to be back in person that they can all rally around the same time, or that we can staff a bunch of different times. We would like to start offering more in-person options, but I think for the time being, at least the ACSL clubs will continue to be online, especially because to keep the costs low on those, we prefer to offer one session with all the students who want to join. That way they can be with all their teammates, and that necessitates it being online. In order to evaluate, okay, so this is a good question. If your student is learning Java somewhere else, in order to place them at an appropriate class level, we would love to meet with them for one of our trial classes. And a trial class is only an hour long. Almost all of our students have done it at some point. Can even be less than an hour if they come in with experience and are like, I know Java, tell me where to be. Most of the time, it's just about getting used to our system, seeing some of the practice problems that we would use in any of our courses, and then deciding if that'd be a good fit for them. So for that anonymous question, I will also post a free trial link in the chat. And that way, if your student would like to meet with us for class, any of our instructors would be happy to tell them which class level to join. And to answer these other two questions, the video recording will be sent out to all attendees. Anybody who missed this as well will also get a recording, so no worries there. And if your student is in CSO2A and only 14 years old, they should feel very proud of themselves. And they could probably take ACSL intermediate or senior. As I mentioned, those are the same prep club, ACSL 3, which we'll look at in a little bit. So if you're at that advanced level of coding, CSO2A is our level 6, probably second from the highest tier of classes that we offer. And also about the same difficulty as like a USACO bronze, or maybe even USACO silver level problems. They could definitely join the ACSL team with the intermediate or senior team. And I would encourage them maybe to start with intermediate and see how it goes from there, just because not all of it is programming. Let's see, Mingfei, to answer your question again, the video recording will be sent out to everybody. Even people who couldn't make it tonight will get a link to this recording, so you'll be able to review the first half hour. All right. Just to show while I'm looking at ACSL, what a practice problem looks like, I'd like to bring in another link. And before we get to USACO, I'm just going to show what the short answers from a past ACSL contest look like. And these are prep materials that we have as a school that we offer as part of our prep club as a resource. And so being able to look back through the past 40 years of problems is, as you might imagine, really valuable, but not necessary. There's also resources on the website if your student chooses not to enroll in a club. And these are the sorts of problems that might be present at the elementary division. So you'll notice these are all the same type of problem. So they're only learning one topic as they're preparing for this contest, and that's computer number systems. And to be honest, even as an adult, when I was preparing to teach these classes, some of this looks a little bit like gibberish. Like, what is A68 underscore 16? Like, where are these numbers coming from? But it is a very logical system and something that I think is important to understand just as a basis for other mathematics. We kind of take for granted that all our numbers are in base 10. You know, we count to 10 and then we add another digit and so on and so forth. But computers use binary numbers, and sometimes they use these octal or hexadecimal numbers as well, base 2, base 8, base 16. And being able to convert between these two, knowing that like, okay, this is 255, but if I want to know what this number is, I have to add like 4 plus 8 plus 16 plus 32 plus 64 all the way up. And learning to do that quickly can really reinforce students' math skills and also translate really well to programming skills. Not to mention these hexadecimal numbers are what all the colors use on the internet and pretty much everywhere else. So that in alone can be a helpful skill. And then There are some word problems in here as well. So even though it's short answer, you might have to read a sentence, think about it a little bit. If you're familiar with colors, you might know that, okay, the last two here, C4, that's the blue component. And what's the difference between that and this number in this base 16 hexadecimal system? So it's, I mean, at first glance, definitely advanced for 3rd through 6th graders, but once we break it down, and I think the benefit of the prep club is really breaking down each type of problem into a formula they can follow. I think it can be really empowering for students to see something like this and know that they can read it and figure it out. I'll keep us going in the interest of time. I could come back and see other or look at other ACSL short answer programming problems at different levels if folks are interested. But just let me know towards the end if that's something you'd like to see. And to talk about the USACO a little bit more, this is one of the most challenging and prestigious computing competitions. So we have students and parents a lot of the time come to us and say, how can I start learning for USACO? How can I start competing? And my answer is usually if you're not coding at a certain level, it might not be the best idea yet, just because your student could get discouraged. They could just have a bad time and not want to continue. And that's the last thing we want as a school. We want students to be really engaged and loving whatever they do with code. And so for our classes, we like students to be coding at our CS01B level 5 class level for the reasons I mentioned earlier. They'll have a lot more object-oriented programming skills at that point. They'll know how to handle file inputs and outputs a little bit more. And they might even be at a point where they could go to this website, usaco.org, look at the past contests and start to figure it out themselves, or at least submit an answer. And if that's something they're maybe struggling with a little bit, even though they want to try it on their own, we do have a fairly helpful FAQ that we offer as a free resource. Students can use our video guides to get started. And I do encourage students of any level to test this out if they're excited about it. We don't want to tell students like, oh, just wait a few years, because we know that can be the worst thing to hear as a kid. But having a free resource to get started and then knowing that, okay, once I've reached this level of coding, I can take a prep course with my peers if I want to. I can probably tackle these things a lot more easily on my own, could give them a very clear path to follow. So that's most of what I feel like I've talked through most of these divisions at some point. The promotion system is a little bit weird. So to highlight that a bit more, everybody starts off competing in the bronze division. And every time there's a contest, a student will have the opportunity to be promoted to the next level. And when I pull up the website in a minute, we can look at the numbers involved there and how that goes. But it is challenging, it is competitive. You are not trying to place in the top 50. It's not like somebody can take your spot if they do better than you. It's getting a certain score based on their scoring system. And if you do really well, if you get close to a perfect score, you can actually be promoted during a contest. So a mark of a student who's really well prepared, maybe too advanced for the bronze level to begin with, is they may be promoted to silver during the contest and be able to take another contest if they want to. Now that does happen so rarely, and when it does happen, I feel like students are usually not super well prepared for that next level. It's not something we count on or even advertise that much in our courses, but it is a cool aspect of how these work. I think that if you do so well, you can skip ahead and then compete at that next level until you're promoted again. This usaco.org website, which I'll pull up for a second, looks like it was built in the 80s. We haven't updated much since 1989, but it does have really helpful things on it, especially the past contests. And I believe there's results on here as well. So if we go to our December contest from a year ago, you can see this table of how many people participated. There's the most in the US, but obviously many, many countries represented here. You can see which languages were the most popular, Java second. I'm actually not sure where this 11 comes from for C++ 1.1. C++ is up there as well, as is Python. And you can even look at the contest problems. The numbers I was referencing earlier are these numbers of There were 7,858 total participants. About 6,000 of those were pre-college high school students, and 1,300 of them scored 800 or higher. So not definitely nowhere near 50%, but way over 10% of the people, probably closer to 20%, did score well enough to be promoted in this contest. So it's not incredibly hard at this bronze level to see those kind of results. And as you go up, and anybody can access this website, I'll send the link out later as well, you'll see that they become much more selective. So from silver to gold is where a lot of people practice for months, if not years. You'll see there's only less than 200 out of 3,200. And then from gold to platinum, it's even more competitive. So there are only 945 competitors. And I think at this level, they just, give some detailed results of who's promoted, which may or may not include names. I know we've had trouble finding if our students did well here, but you really just have to look in and see, whose names are here, but not that many scored above 800, like really just these first, 50 or so rows. So it does get very competitive at that point. But the good news here is that anybody who wants to can come in and practice some of these problems. You can see the problem itself, some test data for it, and the solution. Not always in the language that you code in. So this is where students can start to pick up that skill of translating or transcribing programming languages. But some of the problems are, and I had one picked out earlier because it's, I think, a funny one and easier to understand. Things like this lost cow problem they all have to do with cows, just kind of a funny aspect of these. And something like Farmer John's looking for Bessie, he has to walk back and forth along the fence. Given the starting position of Farmer John and the cow, how far will he travel? This is a fairly basic problem, but you can see how writing an algorithm that does this really fast for really big numbers, either of these values can be the range 0 to 1,000. So again, not huge, but important, and more important as they progress to do things very efficiently. One thing that USACO tests on. So I know that was a lot of talking since our last slide. I'll take a look at the Q&A again. If you're a sixth grader in Fund 3A, it's really up to them if they want to do elementary for a year. Knowing they'd be at the older end, and however that feels to them mentally might be a good thing or a bad thing. And if they would prefer to do the junior level, I think that's also totally fine, just a little bit more of a challenge. And one thing you could ask them is how much do they enjoy programming? If they are excited for a competition where they actually run some code, write some code, junior level might be best for them. If they just want to get their feet wet, learn about ACSL, try some problems, and not have to work particularly hard the first time around, then they can do that as well. To answer a couple more of these, if your son is in CS01A and 14, math is pre-calc, and what level of USACO and ACSL test should we register? For CS01A, I believe it's still, as I mentioned earlier, just a little bit early for USACO, though he definitely could go ahead and register on the website. And I'll post that FAQ link in a little bit because that's the best source for our free guides of how to get started. The ACSL, though, if he's already coding at that level, he could be he's 14, he could be in the junior level, he could probably be in the intermediate level. He'd probably find that an appropriate level of challenge, and then could continue at intermediate for a couple of years if he wanted to before trying ACSL senior. And at that point, honestly, if he wanted to spend more time just doing USACO, focusing on that, that would be fair as well. To answer one, I'm actually going to get to hackathons in a bit, so I'll leave that one for now. I'm just going to take a quick glance in the chat as well. And I'll let Wendy answer most of these. Yeah, these seem like they will be answered. And I'll come back to that question about hackathons. That's a really good question and something that I definitely plan on addressing in these slides. So that's the deep dive on USACO. There's a lot to understand, but the good news is as students get to this level, they are more than capable of understanding and starting to prepare for it on their own. Even just reading a contest problem and thinking about, without even writing any code, how they might try and solve that problem in their head can be really useful and can start to get them thinking about these things even before they might want to compete in a contest or take a prep course. For these USACO levels, if a student has competed in it, maybe they've taken a prep course before, we also offer these study groups, which are actually starting right now. I'm not sure if anyone's a parent of a past or current USACO student at this point, but especially if they took maybe a prep class over the summer, say they took CS90, the USACO Bronze Prep class, and are still trying to do more preparation for USACO Bronze contest this year. These study groups can be a really good way to prepare more collaboratively with other students. I've found that the courses we offer are really informative, but they tend to be packed with that information, such that an instructor will give a lecture, we'll ask students questions, we'll walk them through how to do a problem, we'll assign sometimes a decent amount of homework solving these skill problems. And it can tend to feel pretty independent and focused, whereas a study group still has that aspect of focus to it. But students can really work together to solve a problem in a group setting, to have a little bit of guidance from an instructor, but really bring in the problems they want to see solved that they feel they're the most lacking in at a certain point, and gain those strengths. So I'm a big advocate for the groups and the prep clubs. Obviously, the prep courses are really great as well. But I think the more we can bring students together to work collaboratively in solving these things, the better. Going on, see, here we go, to other competition options. We have support for these things, maybe not to the same level as USACO's ACSL, and those were the focus of the seminar, but I didn't want to be remiss in not bringing these up. We offer robotics for all ages, and Suya, one of our staff, actually wrote up a really great FAQ that I can send out after this as well. Just because these don't get always talked about as much as other classes, but there is a lot you can do with robotics. And personally, I had the most fun as a kid when I could move things around. I ended up majoring in mechanical engineering in college because I love that physical aspect of things. So huge advocate for these. They can be really fun, and they do involve a competition aspect at the higher levels. Students can bring their creations to the Young Inventor competitions at regional and sometimes even national levels. And we've had students place very well in those. Another opportunity that's very prestigious is the MIT Primes research competition. Not a competition in the sense that your research is competitive, but getting in is very competitive. And we actually have some former students, current TAs, even some current students who are taking part in this right now, going to an MIT Primes conference this weekend, which we're very excited for them to already be doing pretty groundbreaking research at a high school level. I think is extremely impressive. The option of science fairs we talked about a little bit tends to be a more local option. And hackathons is a big one. That was one of the questions that came up earlier. We do have a list here, which I could send out at some point. It has the MIT Primes application in it. It also has some other things, but then this long list of hackathons, some of which are local, most of which are online, so they can be taken from anywhere. There's a University of Toronto one here too. And so some of these might be passed. I know this is a 2020 link that I should remove, but they could be good to go through. And honestly, hackathons tend to be pretty tech savvy in that they can advertise on the internet fairly well. So if you're not sure quite which one or what's out there that might fit your student, search around or asking one of us. We'll be sending out links to meet with an admissions advisor or one of our staff for a consultation after this. Could definitely bring that up there if you're looking for the right level of hackathon for your student. In terms of what preparation we offer for those, the hackathons are one we're still figuring out how to best prepare students for and welcoming suggestions on, because we haven't seen the most interest in what we've offered in the past, which has been a week-long course on hackathon skills for advanced students. And it is a hard topic to tackle in a course just because it tends to be so unique to the product you want to create in your hackathon. You might be doing web programming, you might be working on the back end of an application, you might be working with databases. And I think that can be fairly empowering and eye-opening as well for students if they have a certain skill set that maybe they learned on their own because they're passionate about. They're not sure if it'll ever do them any good or if any of their friends ever care about it. but bringing that to a hackathon, it might be just what a team needs to make that really polished, finished project and to win some prizes. So we believe that offering students a really strong background in programming and algorithms will translate the best to any of those hackathon skills. But we are open to suggestions as well. If you have a course or an area of knowledge that, especially if your student has been to a hackathon and was really like, oh, I wish I knew that, I didn't feel prepared with that for my KT by classes, that's feedback we'd love to hear and start working into our programs. And advanced students who are at the level of any of these may also pursue advanced coursework. They might be in an IB program or taking the AP exam. And we know our students are very busy, especially if you add like a sport or an instrument on top of any of these things. That's a very full schedule. So we don't think it's necessary to do all of these. Maybe if you're a motivated student or the parent of a motivated student, you can suggest these as different options, but really any of these are, I think, equally desirable or equally impressive tracks for them to follow. It's not like they have to hit or check all of these boxes, because any one of these can suck up a lot of time. Moving on real quick, I just want to offer this little grid of things that we offer in terms of preparing students for any of these. And I believe most of you, if you're here, might have gotten notified of these in an email. Specifically, USACO prep courses and prep clubs, as I mentioned, are for students, typically for students in CS01B and above. Now, if your student is new to KT Byte, welcome. We're so glad you're here. We would love to have them in for a trial class using that link I sent earlier. And we have had instructors meet with a student and say, oh, you're good to go. You can go straight into the silver prep course because you have all these skills. Or you haven't taken our CS01B class, but that's okay. You can take the bronze course because you have the programming skills. And maybe even if Java isn't your first language, you have plenty of information that you can use to get started. Speaking of getting started, this link is the one I mentioned earlier with our FAQ. And I'll share this for a second. It has a list of pretty comprehensive questions in the table of contents. And if your student's really gung-ho, just wants to get started, I would skip right to the end with the video guides. And these will take them to links for setting up Eclipse, the development environment that we use for submitting problems, a basic guide of writing a solution, submitting a problem, and a template file that we offer to students as a way to just start with some very basic code in order to just plug it in. Or this code handles your file input and output. So if students have this ready to go, they can just start working the problem immediately, as well as a guide on the submission. So these are all video guides. None are over, I think, 15 minutes. So they can be a really helpful way just to test the waters a little bit for students like, maybe I am ready for this. Maybe I can just start on my own. They can watch these and see how it feels. So send this in chat as well. If it gets buried there, I'd be happy to provide it in an email. Just to answer the last question that I see lingering there, I do believe CS00A is a really helpful class for trying ACSL, especially at that junior level. And I could pull up a junior level programming problem if you'd like, but it is a very similar level of coding to CS00A in terms of the concepts you need to know. And I think similarly for 00A and 00B, depending on your student's age, they'd probably be well suited for either junior or intermediate ACSL. And as I mentioned earlier, some of the age divisions pieces of that also have to do with math skills. So if they're at a high school level of math, they're probably more suited for intermediate. If they're still in middle school, they might want to take the junior level for a year and then see about intermediate after that. I also will leave this up and go to the Q&A for a second. So Harneet, I hope that answered your question about preparing for hackathons. We believe that we teach the fundamental skills they need to know, and then if there's specific technical skills they need, such as web programming or databases, that's something we kind of wait on parent requests in order to field. If we know that a certain number of students are all interested in learning web programming or all really want to know about databases or front-end programming, that is something we can offer. But we do think the fundamental skills we offer are a solid foundation for any of those. Answer a few more of these level classes. So for a 6th grader in CS00B, I may have answered this earlier, but I think at that point they could do the junior level ACSL and feel very competent in the programming section. I don't think they need to be scared of the programming section at all. And just knowing that the other problems, the short answer problems that tend to be a little more similar to a math skill, might feel more challenging just because they haven't taken those late middle school math classes yet, but definitely not out of their range if they're coding at a CS0 or 0B level. So I do believe that, again, the junior or intermediate, leaning towards the intermediate level could be right for them. Or sorry, leaning towards the junior level over elementary. Sorry about that. See that Wendy is answering about the robotics programs. Those are all virtual for now. We do hope to start bringing them back in person just because that is so hands-on, but our robotics instructors are really fantastic and do a great job of handling it online. Oh, and a great question about development environments. So Eclipse is the IDE or development environment that we choose to use. It's what we have taught in for years in our advanced classes, but other IDEs work just as well. And if your students coming to us, I would say at least try and learn Eclipse. It's probably not hard to get started in if you're used to VS Code or Jupyter Notebook or any of those other IDEs. But you can write code in any of those for either of these contests. At the end of the day, you're just submitting a .java file or a .cpp file, whatever coding language you use. The file type and the language inside it is what's important, not what development environment you created it with. And thank you for all those really insightful questions. I hope those are useful to other people as well. One thing I did want to mention about all of these, and sort of a favorite point of mine, if your student's choosing between like sports teams and computer science and math team, and I know there's even like physics Olympiad if they're in high school, that computer science, being a relatively new science in the grand scheme of things, still doesn't get as much attention and popularity as some of those others from contestants. And you may remember seeing those USACO numbers earlier. They're still in the order of, thousands of people competing in USACO bronze, which is a lot, but it's not in the order of those tens of thousands competing in these giant international math competitions or science competitions. And so similarly for robotics, I believe for students who are passionate about these things, it can be really empowering, really cool for them to see recognition on a regional or national level, which might not be the case for them in sports or even in a math or physics competition. I know for a lot of sports teams, it's a big deal even just to make it to your state level competition. And we've had several students placed nationally, either in USACO or in a robotics convention, or ACSL is already nationalized. Some students, I believe from all of our teams last year, got invited to the National ACSL Open at the end of the year for only the best and the brightest students at each level. And so it can be very exciting to feel that sense of, oh yeah, I am part of this greater movement throughout the country, throughout the world, and being recognized for it. Some of these links do take to our different robotics clubs, which I'd be happy to speak to more if folks are interested. I haven't seen a lot of robotics questions yet. And thank you, Wendy, for answering all those great questions in the chat. Going on, I would like to leave a little time for Q&A. I know we've been doing it so far as they come. I will also go back to our registration and see, just to make sure I didn't miss any of those questions that came in when you all registered. But yeah, just take a moment, think about it. If there's anything that hasn't been answered yet, anything you're still wondering, please share that with me. I'm also going to finally end our entry poll. It's been a minute. Share those results. And I will also make an exit poll live just to get a little more information from you before you leave. It's great to see out of the 48 people who answered, over 40 of you, this is your first seminar. So I'm so glad you can make it to this experience. I hope it's been helpful. We do try and offer these at least once, usually twice a month. So if you found this informative, we'd welcome you back at any point. And I'll share those results too in case other folks are interested. Actually, I may not be able to share them. And if you want to see the results, you can see them right now. I will then do the exit poll in a second. And this final poll, just to gather a little feedback, whether you found this useful or not, and just a little bit about whether you think after listening to this, it would be helpful for your student to enroll in one of these competitions, and also what seminars you'd love to see in the future. As I said, we're hoping to keep offering these once every 2 weeks, so plenty of opportunities to see really anything you want to come out of these. The final question, if you'd like to be contacted for a one-on-one conversation about any of these options, feel free to answer however you want. And we will also provide a link in the follow-up email where you can sign up for a meeting with us. So no pressure, but if you are interested in what you heard here or just want a little more information in a more conversational setting, we're happy to offer that as well.
Mark, we have a couple of questions in the
Sure.
chat. Yeah.
Thanks, Wendy. I'll scroll back up to those.
Would pre-calculus be the level to start learning about AI?
Usually AI is very statistics heavy. So a lot of our AI students are either self-taught or at a late high school level where they might be learning some statistics. I don't think calculus figures into AI as much, at least not the machine learning that we teach. That said, I don't think math classes are as important as programming skills to start down that road of artificial intelligence. We do very basic artificial intelligence even in our lower level programming classes. But for those more advanced machine learning classes, we tend to ask students to be similar to USACO, taking our more advanced courses like CS0 or 2A, just to have that knowledge of algorithms, just so the code they have to write isn't so much of a challenge as just learning a new way to write it.
And there's another question about how much time will they spend on these courses? Will there be homework or?
Yeah, that's a great question. I did forget to mention that. So for the ACSL, just registering for the team, if you're just on the team, it's up to students how much they want to prepare. And that could be a little, it could be a lot. If they do choose to join a prep club for a little more structure, and I believe those are all starting this week or next week, if they'd like to join, those will meet once per week for an hour a week and have optional homework. So they can come online in the evening for an hour, just like their regular KT by class if they're already in one. It's much less progressive. It doesn't build on itself as much. So if they need to miss a class for sports or they're just tired that day, that's totally fine. We understand. And there are recordings of those as well. But the homework for those prep clubs is optional. The homework for the USACO courses, since those are an actual course, we do expect students to complete the homework. It'll be part of the report card. And I believe that's for the best as well. If you're trying to do well in USACO, spending an hour a week in class and then maybe 45 minutes a week on the homework is probably a good level of things to do to prepare. Now that can be a little bit different in the study groups. If a student is in a USACO study group and wants to just join for an hour a week, talk with their classmates, figure a problem or two out, and have that be the practice time, I think that can be a little bit lower time commitment, and that's okay. But that is why we have students in those study groups with more of a USACO background already. They're not learning these algorithms for the first time. They're more so practicing them, and that could be fine to do for just an hour a week. The mentors for the ACSL prep clubs, yeah, I believe I could. I don't think I have picture bios I could share about them, but I'm happy to share about them verbally. Their names are Aaron and Janet. Both were either are or were computer science majors in college, and both competed in the ACSL senior division and USACO as high school students. And so I believe Aaron will be taking the junior and elementary ACSL clubs, and Janet will be teaching the intermediate senior ACSL club. I believe Janet's background is she also works on artificial intelligence for Facebook, so she has that industry experience as well. And both of them are really great instructors. They've been teaching our classes for multiple classes at this point. And I feel really confident in their ability to lead those prep clubs and to have a good time with it as well. To answer this anonymous question in the Q&A, how would the process be for the ACSL competition through KTBite? The student would register for a team, and then would the team meet some days during the week with instructor? How would be the step-by-step? The way we handle that is, yes, the student would register for a team, and if you needed help placing them on a team, that's an option as well. The team would meet, the team as a whole doesn't meet, though we do send updates to everybody on the team, either by email or by signal message. We may send a poll to see if there's a better messaging app we could use instead of Signal. I know it's not the most popular, though it is what we use as a company, so that's why we used it last year, if anyone was around last year. And that is the extent of coordination at the team level. The prep club does meet every week, so there is a fee associated with that for the prep club instructor and the classroom time, but they would meet once a week through the spring, through all of the ACSL contests. And it would be once a week, an hour a week, like our regular classes. And as I mentioned, it's more, I don't want to say okay to miss those classes, but we don't grade them in the same way, and students are encouraged to be there all the time, but we understand if they have to miss. And if your son is taking CS0MB right now, the teacher of his class would have more information about these. So I can say pretty confidently his teacher is either myself or Andrew, who's also our USACO instructor for most of those prep courses. And I'm not sure what you mean by invite to the competition, but we would definitely be able to give them more information. In terms of USACO, as I mentioned earlier, it's more of a self-invitation, self-registration process. And so your son would be able, with our help, to go on the website, register, and start taking the competitions. All right, and with that, we are slightly over time. So unless there are other questions at this point, I'm going to wrap things up. But thank you so much, everyone, for attending. It was really great, even through this little exchange, to meet all of you. And I can tell you're really invested in your children's learning and how they can progress through these skills, which is really great for me to see. I'm glad they have such great support systems at home. To answer this one final question from Rashi, can KTBite help in college applications? What we tend to do is for students, we can write a testament to what students have learned in our classes for sure, and help students if they have these questions of like what to highlight when they're writing their college application. And if your student takes through our CS01B course, they would also be qualified to be a teaching assistant with us. And I believe that's typically where we start writing recommendations. If they're a teaching assistant and we actually have that rapport of getting to know them. I was once told that the worst kind of recommendation is one that doesn't really say anything, because then it kind of shows you don't have good things to say. So we don't want to do that. But if your son or daughter or child is at a level where they'd like to be a teaching assistant with us, we'd be happy to mentor them in that role and to write them a college recommendation eventually too. All right, I see folks starting to leave. So thank you so much, everyone, for joining, and we hope to see you at a seminar in the future. You'll receive an email tomorrow with the recording and also some of those links I mentioned, and including a link to sign up for a consultation with us if you have any further questions. Goodbye. Hope you have a great night.